Hi, my name is Mears, and for my Kinematics final project, I created this crank shaper quick return mechanism in SolidWorks and 3D printed it in order to analyze it. This quick return mechanism is made out of 5 different parts: the base, the driving arm, the rocker arm, the link arm, and a block. In order to analyze this, I put a ruler here on the base in order to measure the displacement of the block. The driving arm has a circular plate attached to it and has a notch every 10 degrees. And there is a spot marked on the base of the quick return mechanism to measure the angle of the driving arm. I then collected the displacement of the block for every 10 degrees. These measurements were put into an Excel sheet and graphed for position versus the angle of the driving crank, and derived for the velocity and acceleration graphs. With those graphs, I could determine the angle of the cutting stroke and the angle of the return stroke. I created this so I can analyze 2 different time ratios. One when the driving crank was 45 millimeters away from the center of rotation of the rocker arm, and one for when it was 55 millimeters away from the center of rotation of the rocker arm. The time ratio that I calculated was 2 when the theoretical was 2.2, and the distance traveled by the blocker I got to be 123 millimeters when theoretically it's 122.2 millimeters. For when this distance was 55 millimeters, I calculated a time ratio of 1.88, and the theoretical was 1.86. And the displacement I calculated of the block was 102 millimeters versus 100. So all in all, this device performed how it is said to, and as you can see, it gives a nice slow cutting stroke followed by a quick return, and that's why it's called a quick return mechanism. Thank you for watching, and have a great day.